Okay, last section for this unit, we're looking at 24-3, solving log equations and identifying extraneous solutions. Extraneous solutions, I mean, you've got the word extra in there. Most of the time when you think of something extra, it's a good thing. You know, it's having something that's extra, that you've got everything you need plus more. The deal with extraneous solutions is they're not something you need. They are extra, but it's an extra useless thing. Alright, so extraneous solutions are not solutions. They're things that don't fit our domain criteria. So it's not you have everything plus more, that if, oh, I lost something, I can use that piece of extra as a replacement. Alright, extraneous solutions are not solutions. Alright, you solve them and you get it as a solution, but it won't count as a solution. Alright, it is disqualified, basically, and that's what we'll talk about when we get more specifically to there. But it does have the word extra in there, but it doesn't mean what we traditionally mean with extra. Alright, last time we were solving exponential equations by taking the log. Here we're doing the opposite. Alright, again, we're looking at the inverse property of logs. Alright, so we're starting off with a log, and we're going to begin by taking the exponent. Why did I write an e? Right, the base 4. So 4 to the power of log base 4 of 3x minus 1. And then whatever you do to the left side, you got to do to the right side. So that equals 4 to the power of 2. Alright, and 4 to the power of log base 4, that's going to cancel out, and we're going to have 3x minus 1 is equal to, and we could write 4 squared, but let's just go ahead and do 4 squared is 16. And then it's just solve. So we add 1, 3x is equal to 17, divided by 3, so x is equal to 17 divided by 3. Alright, well, we want to go through and check that to make sure that it works. So I'm going to go back to my original statement here. So log base 4 of 3 times 17 divided by 3 minus 1 is supposed to equal 2. Alright, that's this original statement. I just, instead of x, I wrote what we got x to equal, 17 divided by 3. Alright, and 17 divided by 3 times 3. Well, anything multiplied and divided by the same thing, it's going to give us log base 4. That would give us 17, and then 17 minus 1 of 16. And so if we kind of go turn it into an exponent, 4 squared is equal to 16. Is that true? Yes, it works. Because 4 squared is 16. Alright. We're given the log statement, so we're going to go ahead and take whatever the base is, so 3 to the log base 3 of x minus 1 is equal to 3 to the 5th. Alright, and then 3 log base 3 cancels, and we're left with x minus 1 is equal to, and now 3 to the 5th. 3 times 3 is 9, 9 times 3 is 27, 27 times 3 is something big, probably 96, times 3, I already did it out, is 243. And then we add 1, and so x is equal to 244. Alright, and then to check, this one's a little bit easier to check. Log base 3 of 244 minus 1 is supposed to equal 5. Well, 244 minus 1, so log base 3 of 243 is equal to 5, and we just went through and calculated that 3 to the power of 5 is equal to 243. And we just found that to be true, so again, we know it's true, so it works. just try a couple more of these because this log base 2 of 2x minus 8 is equal to 3. So go ahead and try that one. I'm going to write another one up here. Should be trying this guy here. All right, it's 2 is our base, so 2 log base 2 of 2x minus 8 is equal to 2 to the third. Those guys cancel, so we're left with 2x minus 8 is equal to 2 to the third. 2 times 2 is 4, times another 2 is 8. Oh, I wrote the problem down wrong. 8 is going to be different. 3, 3, 3. 2x minus 3. That will make everything be a little bit different than I was intending, but bring it back to 3. So we'll add 3, add 3. So 2x is equal to 11. Then divide by 2, divide by 2. X is equal to 5.5. If you'd done it with 8, it would have added 8, make 16. 16 divided by 2 would have given us x is equal to 8. Alright, if we want to check that, alright, 2 times 5.5 is 11. 11 minus 3 is 8, so log base 2 of 8 is equal to 3. And that's, 2 to the third is equal to 8. That's true. Alright, this one, where we're starting off with the 4 in front, all the others we just had log, and so it was kind of by itself. Here, the first thing we're going to do is get rid of that 4, so we're going to divide everything on the left and right hand side by 4, so that cancels. So natural log of 3x, 8 divided by 4 is 2. And then we're going to have to do e to the natural log of 3x is equal to e to the second, and then those cancel, so 3x is equal to e to the second, and we divide by 3, and so x is equal to e squared divided by 3, and there's not really any simplifying we can do from there. That's it. Alright, so that is, if we look at the top, that is solving log equations. Alright, we're going to move on to identifying extraneous solutions. Let's figure out, why do extraneous solutions happen? Alright, extraneous solutions happen because the domain of log functions is restricted to only positive real numbers. Alright. If the solution is a negative, it is extraneous. It is an extraneous solution. All right, and you think about why that is. If we think a log function, let's say it's been shifted right a couple. All right, it has a, so we're not right on top of the y-axis. Most of them are right here along here the y-axis, but it got moved right. All right, it's almost a vertical line coming up, and then it goes over. All right, the asymptote, whether it's the y-axis or some artificial where it's been moved left or right, is the line that the graph's not going to cross. Most of the time, if it hasn't been moved left or right, it's coming right up in this y-axis, which means all positive values of x are okay, all negative values of x are not okay. So if our solution comes out to be -5, all right, well, that's not possible. So we're going to say that that is extraneous, right? Even though the math is telling us it is a solution, our real-world understanding of what's happening tells us that's not possible. Okay, so let's look at one where we have an extraneous solution. Log base 2 of x plus log base 2 of x plus 2 is equal to 3. So we're getting a little bit more complicated. All right, when we're adding two logs, if we want to condense those, combine them into one, all right, the operation when we're doing addition is multiply. So that will be log base 2 of x times x plus 2. All right, just combining those to give us here equals 3. All right, and that is the product property of logs. All right, then to do the inverse property, which is what we've been doing to solve this log, we need an exponent. So 2 to the log base 2 of x plus 2 is equal to 2 to the third. Right, that is the inverse property of logs. And again, 2 to the power of log base 2 cancels, and so we're left with x times x plus 2, and 2 to the third is equal to 8. And if we go ahead and multiply this, all right, this is going to be a quadratic equation. We're going to end up having to factor, all right, because so x times x is x squared, x times 2 is positive 2x is equal to 8. In order to solve a quadratic or factor it, has to be set equal to 0. So we'll minus 8, so x squared plus 2x minus 8 is equal to 0. Lots of different ways to get the solutions from this quadratic equation. We could do quadratic formula, or we could just look at this. This is a super easy quadratic. Things that multiply to give us -8 add up to 2, x plus 4, x minus 2. And when we set them each equal to 0, we get x is equal to -4 and x is equal to positive 2. All right. Again, -2 is not going to work. I mean, -4 is not going to work. But positive 2 will work. So if we try positive 2, log base 2 of 2, so I'm plugging it into the original equation, plus log base 2 of 2 plus 2, and it's supposed to equal 3. And then when we're adding, we end up multiplying, so log base 2, so this is going to be 4, but these guys are going to get multiplied, so 2 times 4, and is 2 to the third power equal to 8? It is. 2 to the third power is equal to 8. But if we try to do the same thing with this guy, it would be log base 2 of negative 4, and you can't do log base 2 of negative 4, plus log base 2 of negative 4 plus 2, which is going to give us negative 2. So you can't do log base 2 of negative 4. You can't do log base 2 of negative 2. And when you combine them, they're certainly not going to equal 3. So we'd want to say that is extraneous, and this is our solution that works. Okay, let's try a couple more, and then we'll be done. Let's see. Log base 4 of x plus 6 minus log base 4 of x is equal to 2. Alright, so when we're doing subtraction and we combine those, log base 4 of x plus 6 divided by x is equal to 2. And then take it, 4 to the log base 4 of x plus 6 divided by x is equal to 4 squared. So x plus 6 divided by x is equal to 4 squared, which is 16. And this looks really awkward, but I mean, in essence, it's just trying to solve. So we're being divided by x. So what we want to do through there is multiply by x. So that cancels. So x plus 6 is equal to 16x. And we want to get the x's together. So minus x, 6 is equal to 15x, because 16x minus 1x is 15. And then we'll divide by 15. And so our answer is x is equal to 6/15, which we want to simplify that. Both of these are divisible by 3. So 6 divided by 3 is 2. 15 divided by 3 is 5. 2/5 is our answer there. And it is positive, so there's no reason to think that it would be extraneous. We want to go through and check to be sure, but no reason to think that it should be. The reason you want to check, and I'm not actually going to check this one, but kind of what I was talking about with you're not ever 100% certain, is that if the problem shifted the log left or right, you could shift it left and it could start right there, and in that case, like -1 and -2 might be possible, or you could shift it right and +1 and +2 might be extraneous. All right, if there's been no shift, then it's purely positive/negative. But we want to go through and check every one to make sure, because let's say it was just this. Oh, you can't see. Say instead of this other part, it was this, just log base 4 of x plus 6. Well, I could actually solve x and get some negative numbers that would work. If I got x is equal to -4, well, -4 plus 6 is +2. You can do log of +2, and so that would be okay. So this is one where, because it's +6, where it got moved left 6. Right? If we are on our graph, there is a asymptote at -6. All right, it got moved left. So there are some negatives that are possible. So you can't just blanket statement and say any negative is automatically extraneous, because it might be plugged into one like this and it might actually work. Okay, so you want to go through and test it, just like we went through with this -4. and tested it out, where we did, okay, log base 2 of negative 4, okay, we can't do that. Log base 2 of negative 4 plus 2 would give us negative 2, so log base 2 of negative 2, you can't do that. All right, so you want to go through and test and make sure that they're extraneous for each one. All right, if we look at, if you want to try just for practice, page 377, to try these. Oh, again, I'm writing and you can't see it. I apologize. Page 377, to try these. Letter C. All right, the answer for letter C is you solve out and you get x is equal to 4, and you get x is equal to negative 1. And negative 1 is extraneous. All right, so if you want to go through and try that one, knowing that these are the answers, and make sure that you can get to those two answers. Actually, it's this. I mean, that's the one answer. This guy's extraneous, so he doesn't technically count. But you want to write it there to kind of prove that you knew that. So even though we know that 4 is our only answer, all right, we want to write x is equal to negative 1 and say that it's extraneous to kind of prove that you were able to figure that out. And then our homework for this section is 378. And it's 3 through 7. Next time we'll be reviewing, and then the time after that we'll be taking our test.